Good morning. Okay, so today in maths then we are going to be able to understand equivalent fractions, and this is our first lesson. I think it's our first lesson out of 3 lessons that we're having on equivalent fractions. So to get our brains warmed up, let's do a flashback 4. Okay, so we've got a clock here where you've got to tell me what the time is, and you've got 4 different questions. All right, so pause the video here so you can have a go at answering these questions, and then we will go through the answers in a moment. Okay then, so let's start off with the clock. Okay, so we can see that the minute hand, the bigger hand, is pointing to the 9. All right, so if we can remember that the 9 is 1/4 all right, so it's 1/4 something. So when this minute hand comes all the way around to the o'clock, to the 12, where will our hour hand be pointing to? Well, I think it will definitely be pointing to the 12. So it is 1/4 all right, so let's just make that a bit smaller. So 1/4 or if you have been able to tell me in digital time, that would be 11:45. Okay, so that's your first one done for you. Let's just move that over there and put it at the top actually so you can see. Okay, right then, so number 1 here, find 2/5 of the number of lemons. So how many lemons have we got all together? Let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have got 10 lemons. So if I need to find 2/5, I'm going to find 1/5 first. Okay, so I'm going to do 10 divided by 5. Oops, that doesn't say divided. Divided by 5 equals. Okay, so if I were to find 1/5, I would divide these 10 lemons by my denominator. And my denominator is 5. So 10 divided by 5 is 2. Okay, but that would just give me 1/5. And the question is asking us for 2/5. So I then need to multiply my 2 by 2, which is going to give me 4. Okay. So the answer here would be 4 lemons. Okay, put that there for you. Right then, number 2. Write 0.3 as a fraction. Okay, so you did tenths last week in your maths. So we should be able to work out 0.3 as a fraction. So if we can remember our place value chart where we have got ones, and then we've also got tens. Okay, so I'm just going to put those there, but then I'm going to put a decimal point because that would come in between the ones and then something that's called if this wants to all work, the tenths. Okay, and then next to the tenths you've got the hundredths. Okay. There we go. Okay, so if we put 0.3 in this place value chart, our 0 would go underneath our ones, our decimal point would go where the decimal point is, and then our 3 would go into our tenths column. Okay, so we've got 0.3, so we've got 3 tenths. So can we write that as a fraction? I think we can. So 3 tenths would be 3, and then your 10 is your denominator, and then you will pop in the middle there. Okay, so 3 tenths. Okay, so that's the answer for that one for you. Okay then, so let's move on to question number 3. Draw a line 65 millimeters long. Okay, so you should be able to get a ruler and you'll be able to draw a line 65 millimeters. So just to help you with that one, how many millimeters are there in a centimeter? Well, there are 10 millimeters equals 1 centimeter. Okay, so if we've got 65 millimeters, then how many centimeters should you be drawing? Well, that would be 6.5 centimeters. Okay, so hopefully you've still got that ruler that we gave you. So you can draw that line. That is 6.5 centimeters long, which is the same as 65 millimeters. And then last question, what is 7 worth in the number 375? Okay, so if you want to go back to use our place value chart, so over here, I'm just going to add hundreds to it. There we go, okay. And we'll just ignore this 0.3 for the moment because our number is actually 375. Okay, so let's just put those in the right order. So we've got 300s, 7 10s, and 5 1s. So what is the 7 worth in 375? The 7 is worth 7 10s, 70. Okay, so there we go. Okay, let's move on then to our equivalent fractions. All right then, so as you can see on the screen, we have got a fraction, and that fraction is a quarter. So what can you tell me about the number 4 here? Okay, so the number 4 is, if you can remember rightly, our denominator. Okay, and that tells us how many equal parts that there are. All right, so if the bottom number is called the denominator, who can remember what's the top number called? It is in fact the numerator. Okay, so well done if you've got those 2 vocabulary pieces right. So we've got our denominator, which is our bottom number, and this one is our 4. So that's how many equal parts there are. And our numerator is number 1, okay? And this is how many of the parts we're using. Okay, so I'm just going to get rid of this. There we go. Okay then, so as you can see, 4 is my denominator, so I've got 4 equal parts. All right, now 1 is my numerator, so I need to show 1/4 using this. So I'm going to get a colour and I'm going to use red so you can see. Okay, and I'm going to shade in just one of these squares, okay, because that's the part that we are using. Yeah, okay, so 4 equal parts because we've got 4 as our denominator, 1 part shaded in because that's the part that we're using, and that's our numerator. Okay, so let's add another fraction into the mix. So we've got a quarter, so I'm going to shade in just like we did on the last one, that 1 part, because oops, that's not very good shading, is it? There we go. 1 part is our numerator, so let's just shade that 1 in. Okay, so our second fraction is 2/8. Okay, so when we are comparing fractions, and we can use the bar model, all right? So you can see the bar model here and the bar model here. Now what you should notice about the bar model is that they are both the same size, okay? So yes, they have lots of different sections in them, but they are still the same length. And that's really important to remember when you are comparing equivalent fractions. Your bar models need to be the same size, okay? Right then, so let's have a look if our numerator, because we've got our denominator as 8, I have split this bar model into 8 equal parts. It's really important that it's equal. And our numerator is 2, so I need to make sure that I am now shading in 2 parts of this bar model, okay, because that's the numerator that we have. So 1 part and 2 parts. It's very difficult to shade in using this pen. There we go. Okay, so what do you notice about 1/4 and 2/8? Because what you should see, and I'll get a big line to go all the way down, is that 1/4 and 2/8 are in fact equivalent. They are the same, okay? Because we have shaded in the same on this bar model and exactly the same on this bar model. They are equal, okay? So actually you could say that 1/4 1/4 and 2/8 they equal the same parts. Let's just get a line to put my line in for the fraction. There you go. And then I'm going to put an equal sign here because they equal each other. Okay, they are the same. All right. So let's have a look at our next slide then. Right then, so this is your practice. Okay, so you might want to pause it here so you can have a go. And it's asking you, is 6/9 equivalent to 2/3? Okay, so as you can see, the bar models are exactly the same size. They have just been split up into different equal parts because we have got different denominators. The first one is split up into 9 equal parts and the second one is split up into 3 equal parts. Okay, so pause it here and see what you can find out. Is 6/9 equivalent to 2/3? Okay then, so let's see, let's change the colour, let's get some bright colours in this time. So 6/9, so yep, 9 equal parts is our denominator, now 6 is our numerator, so I'm going to shade in 6 of these. Well, that's not as bright as I wanted it to be, so 1, 2, 3, 4, 5, and 6. Okay, so 6/9 completed. Right then, let's see about the 2/3 then. So this bar model has been split up into thirds, and this time we're going to colour in 2 of these thirds. So because it's been split up into thirds, the parts are bigger. So 1 part, and oh, that's not a very good one, is it? Let's try again on that one. And 2 parts. Okay, so then what do you notice? Is 6/9 equivalent to 2/3? The answer is definitely yes. You can see that they are the same amount has been coloured in. Okay, so yes, they have been split up into different parts, but there's still the same amount that has been shaded in. Okay, so 6/9 is equivalent to 2/3 and 2/3 is equivalent to 6/9. All right then, so let's see what Ron and Whitney are saying. Okay, so Ron is saying half is equivalent to 2/3 because I have added 1 to both the numerator and denominator. And Whitney is saying half is not equivalent to 5/10 because you have added 4 to the numerator but 8 to the denominator. Okay then, so I want you to have a practice at these ones. I've put the bar models here so you can work out using those. Okay, so they're the same sizes. You've just got to work out whether they are equivalent fractions or not. So pause the video here and you can have a practice at this one. Okay then, so let's see. Let's go to Ron first then. So Ron is saying a half is equivalent to 2/3. So I've got my 2 equal parts and I'm going to shade in my 1 because my 1 is my numerator for the first fraction. Okay, done. So, and then 2/3, so my 3 equal parts, but this time I need to shade in 2 parts because 2 is my numerator. So 1 part and 2 parts. Okay, there we go. Ooh, what do you notice there? Are they equal? Have the same amount of each bar model being coloured in? No, they haven't. So I'm going to write, I don't agree with Ron because, okay, because the fractions are not equivalent. I don't agree with Ron because the fractions are not equivalent as shown in the bar model above. So that's just saying that I've shown that the answer is not correct because I've used a bar model method and I've used the same bar model, same size, split up into different parts according to the denominators, coloured in the right amount of parts according to the numerators, and it is not equal. So I don't agree with him. Let's find out about Whitney then. Okay, so again, a half is equivalent to 5/10. So here's in my 2 parts, and I'm going to shade in 1 because that's all we're going to do, because that's our numerator. I'm going to do it very quickly on this one. There we go. Okay, so 1/2 has been shaded in here. And she is saying a half is not equivalent to 5/10. Well, let's find out. So here I've got my 10 parts, my 10 equal parts, and I'm going to shade in 5 because that's the numerator. 1, 2, 3, 4, 5. Okay then. Oh, well, what do we notice here? Well, I notice that both of those parts are equal. So actually, Whitney is wrong because she is saying a half is not equivalent to 5/10. So I'm just going to move this up here so I can write about Whitney. I'm going to put that there, and I'm just going to make that a little bit smaller. Oh, or maybe I'm not. Let's just make the writing a little bit smaller. Here we go. There we go, perfect. Okay, so here I'm then going to say, I don't agree with Whitney. Oops, not Whitney. And again, Whitney, because the fractions are equivalent as shown using the bar model method. Okay, the same amount of parts, the same amount of bar model has been shaded in. Okay, so that's just saying that we've used the bar model and the same amount of the bar model has been shaded in. So that must mean that those two fractions are equivalent. Okay, so don't forget, you can not agree, you can disagree with both people. Don't get tricked to thinking, actually, I need to agree because the question says that I need to agree. You don't have to. You need to make sure that you show you're working out and then write your answer. Okay, then, so have a look at this one. All right, so this is a practice, and this is for you to try and see whether you can draw your own bar models, making sure that they are the same size, just being split up into different parts according to the denominator. Okay, so we can see we have got 4/9, 6/9, and 4/6. So which one do you think is the odd one out? So just by looking at those ones, those fractions, you might think, well, actually, I think 6/9 is the odd one out because it's the only one that hasn't got a 4 as a numerator. Or you might say that 4/6 is the odd one out because it's the only one that hasn't got 9 as its denominator, okay? So what I want you to do now is I want you to draw out the bar models for each one of these fractions, and I want you to compare them just like what we have been doing so far, okay? So you might want to pause it here and draw those out, and I'll show you what it should look like in a moment. Okay then. So here we have 4/9, 6/9, and 4/6. So as you can see, all of these bar models are the same size. They are the same length. The only difference is that they've been split up into different parts. So these two fractions have been split up into 9ths because the denominator is 9. And this bar model has been split up into 6ths because the denominator is 6. Well, what do we notice then? Well, I can see straight away that this fraction here, 6/9, is equivalent to 4/6. Yeah, because the same amount has been shaded in. So 6/9 is equivalent to 4/6. Okay. Hoping that my line will work now this time as well. Little line. Yeah, you can also say that 4/6 is equivalent to 6/9 because they are. The same amount of bar model has been coloured in. 4/9 would be your odd one out because it is not equivalent. Okay, right then, so your work today then, Silver, you are answering questions 1 to 3 on this sheet that we will send out to you. Okay, Gold, you will answer questions 4 to 7 on this sheet which is attached to the top one. All right, so you've got 2 pages on there. So Silver, if you want to push yourself onto Gold, please do. All right, because you will be able to answer all of those questions nice and easy. Then Platinum, you've got 4 different questions that will be sent out to you on a different sheet. All right then. So if you need any help or any support, please email myself or Mr. Grocott and we will be more than happy to help you. Have fun. Bye.